Okay, this is geometry, the first notes for chapter 3. Note 16, identify pairs of lines and angles. Make sure you put your name, the date, and the class period. Your essential question is, what angle pairs are formed by transversals? This was the activity in activity 3 from the Cambridge Junior. And the answer for this would be there are 5 types of angle pairs formed by transversals. They're called corresponding angles, alternate interior angles, alternate exterior angles, same side exterior angles, and same side interior angles. Alright, we have a bunch of vocabulary, so I'll leave it up here so you can see it and copy them down as I read through them. We slide it just a little bit. It says parallel lines. Our two lines are parallel lines if they do not intersect and are coplanar, which means they're in the same plane. Skew lines are two lines that are skew if they do not intersect each other and they are not coplanar. And a best example of this one, because a lot of students don't understand it, is like saying you have the street with a light post beside it, or like the street in front of the school and the flagpole would be a good example of skew lines. Okay. On the third one we have parallel planes. Two planes that do not intersect are called parallel planes. That's the same thing as parallel lines. We have a new word that I may be saying on the activity 3. Transversal is a line that intersects two or more coplanar lines at different points. So you are drawing lines with a line going through it. This line right here at the top was called the transversal. It intersects other lines. On the corresponding angles, two angles are going to be corresponding if they're in the same position on the lines. The alternate interior angles are on the two lines, but they're opposite sides of the transversal. So if you had two lines cut by transversal, the alternate interior would be lines on the inside of your shape. Alternate exterior angles, if you have your two lines cut by the transversals cutting through it, your exterior are on the outside edges and they alternate across the parallel lines. And then we have in the vocabulary for this time, they have consecutive interior, which in your activity, and a lot of times they'll say same side interior, is that those two lines are on the same side of the transversal. And that would go for the same side exterior that you had in your activity. They'd be on the same side but on the outside, they're exterior. Okay, let me hold that still a little bit, make sure you have them written down. Okay, on activity 1, it says think of some segments if the figure is part of the line. It says which line or planes in the figure appear to be the best description. So on the A, it says which lines are parallel to line AF and contain the point E. If I look at my picture, I want it to be parallel to AF. AF is along this top. And you imagine that being a line. And it has to be through point E. The only one that is parallel and going through E is line EJ. Okay, let me slide that over so we can see what I wrote. Okay, on B, it wants a line that is skew to AF but contains that point. So skew, remember, was a line that does not intersect and it is not in the same plane. So I cannot intersect AF at all, so that counts out this EF, and it's not going to be in the same plane as AF, which means it's not in this white shadowed rectangle or the back shadowed rectangle. So if I'm looking at that, it has to go through E. It's not AE because it intersects. It has to be this one line right here that is ED. Okay. On C it says lines perpendicular to AF that are on that point. It has to be perpendicular. Must go through E. On this top edge here, let me get a pen here. This entire top is a rectangle, and we know rectangles have right angles. So that means this line right here that's going through E meets it at a right angle at that corner. So that means AE is perpendicular through it. Okay, on D it says we want planes that are parallel to the plane EFG and contains point E. Alright, so the plane FG and H Okay, I'm trying to find where G and H are. Let's see, this is A, B, C, D, E. Okay, so this back corner, they got a little A down there. There's the F, J, and I. Let me see here, it'd be E, E, F, has to be G, H, I, and J. So G must be here, and that, where they have an A, should have been an H. So F, G, H, I, J. So my best estimate is they're talking about this pentagon in the back. If I color that in so I can see it a little better. Okay, so that pentagon in the back is parallel to what other plane that must have point E in it? Well, pentagon with pentagon has to be this front pentagon here. So I'm going to say plane. And when I name the plane, all I need is 3 points. And since we have to have E, I'm going to conclude the letter E. So I'm going to go E, and that happened to be the last one. So let me rewrite this in order. C, D, E would be an example. Realize I could do any of those combinations to name it. Okay, I have postulate 13 is a parallel postulate, and it says if there is a line and a point not on the line, there is exactly one line through the point that is going to be parallel. There is exactly one line through P parallel to L. So to give you a little picture, this is saying we have a line, say line L, and a point that's not on the line that they're saying is P. And what that means is that they can construct a line that goes through P and is going to be parallel to L. There's exactly one line that can do that. Okay. On postulate 14, it has perpendicular postulate. So if there's a line and a point on the line, there is exactly one line through that point perpendicular to the given line. So for this picture, basically you have a line, say line L, and a point up here P, and they're saying that we can construct a line that will go through L and through P that will be perpendicular, and there is only one line that will actually do that at a perpendicular line. Okay, second page on the back, which is my page 2. I have A very bright light. Let me focus. Okay. I'll work on the color of this. It says example 2. We have a triangular prism in the box over to the side. It says think about each segment drawn as part of a line. So imagine all these are actually lines drawn. They just didn't have them. To fill in the blank whether it's parallel, skew, or perpendicular. So here it's saying DE, this line here, and CF. CF is here. Okay, if I'm looking at those two lines, do they intersect? No. So they're not perpendicular at all. They do not intersect at all, so could they be parallel? Well, to me, they have to be in the same plane to be parallel. E is in the vertical one triangle, and FC is in the rectangle on the bottom. So that means these are skew lines. Okay, let me turn off the light. Okay. Alright, on B it has AD. Where's AD? Let me use pink this time. AD is this back corner edge. BE is the top edge here. And CF is this line that we had in the first one. All of these lines appear to be what? They're not intersecting at all, and there is actually a plane that goes through each one of those. So they have to be parallel. Okay. Alright, so let me look at C. Let me pause. Okay, on C it has plane ABC. ABC is the back triangle, and plane DEF. Those two planes are the triangles and they're of a prism, therefore they have to be parallel. And then on D it has BE, which is this top line, and plane AB, which is back here. And these are intersecting lines, so I know they're not parallel and they're not skew. So that means they must be perpendicular. And remember, this side is a rectangle, which they all meet at right angles. And that's what's saying that this is a perpendicular line. Okay, on number 3, it wants us to identify all pairs of angles of that particular given type. So let me get my black pen. We're going to do corresponding angles. Well, we have actually 4 sets of corresponding angles. And for instance, I have angle 1 will be corresponding with angle, and angle 1 is on the top line, top left line. On the second line would be angle 3. These two angles are corresponding. Then, like I say, angle 8 is corresponding to angle 6 because they're on the top right hand side of both lines. Then I can go on bottom. Angle 2 is on the bottom of the top line, top left line, and therefore angle 4 is in the same position. And then last I would have angle 7. Angle 7 is in the bottom right side of my line on the top line, therefore 5 is in its corresponding spot. There's my 4 sets of corresponding angles. Okay. The alternate interior angles, there's only 2 of them. The interior means I'm in the middle. This represents my inside area. Exterior is the top and the bottom are exteriors. Interior and alternate means it crosses over the the transversal, which your transversal happens to be the line that goes through both of the other lines. Therefore, the alternate interior angles has 3 with 7. And then there's another set that goes the other way, 2 and 6. Alternate exterior. Exterior means I'm dealing with the outside numbers, which is 1, 8, 4, and 5. So 1 will be alternate to 5. And then I have the other side, 8 will be alternate to 4. And then we have one more, this consecutive interior, which is same name as same side interior. Just so you know, consecutive is the same thing as same side. I have 2 sets of these on the same side, so I'm going to pick the left side, and it has to be interior, which means it's angles 2 and angles 3 are same side interior. And then I have the other side, angle 7 and angle 6. Those are all my angle names. Alright, your independent practice is they want you to identify the types of angles you have. You're going to fill in the blank with either a corresponding alternate interior, alternate exterior, or consecutive interior. And there's your picture. Make sure you answer your summary.